Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. To your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here are another problems in calculus. I hope that through this, your knowledge in calculus will be enhanced, particularly on the interpretation of the derivative and techniques of graphing, even though I plotted here the graph of functions by point plotting as well as the graph of its derivative interpreted as slopes, but the slopes are estimated in these two problems. So if f of d is equal to 6 over quantity 1 plus d square, find f prime of d. Check to see that your answer to part A is reasonable by comparing the graphs of f and f prime. So this is our guide for the derivative of this function. Derivative of constant over u is negative constant over u squared du dt. And remember the derivation of this, we simply transform this into cu to the negative 1, then apply power formula to arrive at this. You can also derive this by, you can also differentiate this by the power formula if you want. So I just use this guide because anyway, this is derived by the power formula. So this is the constant c, so f prime of t, derivative of constant over variable, is equal to negative constant times the derivative of u, which is 1 plus t squared in this case with respect to t. So the derivative of 1 plus t squared is 2t all over variable 1 plus t squared quantity square. So simplifying, f prime of t is negative 12t over 1 plus t squared quantity square. So we now plot the graph of f of d first. 6 over 1 plus t squared by point plotting when t is plus minus 4. So this is the first point supposedly. Then you also use your calculator to estimate f of d, corresponding f of d. So this is 6 over 16 to be exact. And 6 over 16 is 3 over 8. And 3 over 8 is 0.375 supposedly. So when t is plus minus 4, f of t is plus minus 3/8 or plus f of t rather is 0.375 or 3/8. Then when x is plus minus 3, 6 over 10 is 0.6, so that's why you have 0.6 here. When t is 2, this is 5, so 6 over 5 is 1.2. When t is plus minus 1, this is 2, so 6 over 2 is 3. When t is 0, so this is 1, so 6 over 1 is 6. Then when t is plus minus 100 or plus minus infinity, 6 over 1 plus infinity squared or 6 over infinity is 0 but positive. So we have 0 which is almost 0 but positive. So that's the idea. Then for f prime of d, first we have plus minus 4 and substitute here. This becomes 17 squared in the denominator. and we have negative 12 times plus minus 4. Then f prime of t is plus minus 0.17 to be as its approximate value. When x is plus minus 3, then f prime of t is plus minus 0.36. You just use your calculator. Then when t is plus minus 2, then you'll have negative 24 over 5 squared, 24 over 25. So that's why you have plus minus 0.96. Then when t is plus minus 1, this is 2. 2 squared is 4. Negative 12 over 4 is 3. So plus minus 3. When t is 0, numerator is 0, denominator is 1. So 0. When t is plus minus 0.6, then it is, use your calculator, plus minus 0.39. So we are now ready to plot all these points, then connect them with a smooth curve, as well as for f prime of t. So the graph of f of t here and f prime of t will be as shown here. So we have here the green curve, which is f of t. These are the points. And for the red curve, that's the f prime of t. So plus and minus infinity approaching 0, then plus minus 4.37 for f prime of t, plus minus 4 plus minus 0.17 here, then plus minus 3, negative 3, negative 3.6, positive 0.3 is negative 0.6. Plus minus 3 plus minus 0.36. So if this plus, it's if it is positive 3, it is negative 0.36. If it is negative 3, it is positive 0.36. So that's the pairing. For positive, the partner is negative. For negative, the partner is positive. So first, these points plotted as shown here. So this is f of t, and these are the points. So negative 3 plus minus 3.6, positive 0.6 here. Then plus minus 2, 1.2, 1.2. Then plus minus 1, 3 here. Then when t is 0, it's 6, the origin 1 point only. Then when t is plus minus infinity, it's almost 0. So the green curve is above the x-axis. So that's the reason why. So for its derivative, we have beginning with positive 4, then negative 0.17. Negative 4, positive 0.17. So negative 4, 0.17 positive. Then if very large, this is very large negative. Then if it is very large but negative, the numerator is positive, the denominator is positive, approaching 0. That's why it is above. the curve. Then negative 3, so it is positive 0.36 here on the red curve. So negative 4, positive 0.17, then positive 4, negative 0.17 here, negative 3, positive 0.36, positive 3, negative 0.36, positive 2, negative 2, positive 0.96 here, then this is so positive negative 1, negative 1, positive 3, then positive 1, negative 3 here, then positive 0.6, positive 0.6, negative 3.89, which is this, and negative 0.6, positive 3.89, which is that, then 0, 0. So that's why we have this graph of f prime of d. Then here, the unemployment rate U sub d varies with time. The table from the Bureau of Labor Statistics gives the percentage of unemployed in the U.S. labor force from 1991 to 2000. So we plot U of D 6.8, which is here, when year is 1991, 1992 7.5, 1993 6.9, 1994 6.1, 1995 5.6, 1996 5.4, then 1997 4.9, 1998 4.5, 1999 4.2, then 2000 4.0. So this is the graph of U sub d. Connect them with a smooth curve. Then we estimate the value of U prime of d. We just construct values of U prime of d. So first we draw tangent here, and that slope is positive, and it is approximated as about 0.9. So you just compute the rise, which is about 0.2, 0.4, 0.6, 0.8, 0.9 divided by 1 year. So that's why it's 0.9. Here, that's positive but almost 0, so that can be approximated as 0.1. Then tangent to this point, that's a negative slope, so we can approximate that as negative 0.8. Then tangent to this point here, the blue line, it is also negative but less than this, so negative 0.65. Tangent to this point, that's negative also, so approximately that's negative 0.3. Tangent to this point, so that's almost parallel to this, so you can estimate that as negative 0.3 also. Tangent to this point, that's negative 0.4. Tangent to this point, so that's negative 0.3 again. Then tangent to this, that's also negative, so negative 0.25. Then finally here, at 2000, the slope is approximated to be negative zero point 0.2. So with much more detail, you just estimate the slope. You may magnify that part, then then the horizontal is always 1, then the vertical should be estimated intersection of the vertical axis and the horizontal line. So you just get the vertical distance between adjacent points. Then, of course, beginning with this point up to here, the slopes would now be negative, except for these first two where the slopes are positive. So that's it for this video. I hope that you know how to estimate slopes also.